Measures of position here. Basically, measures of position are going to consist of three things here: our z-scores, our percentiles, and our quartiles. We'll focus today on z-scores and on percentiles. In a separate lesson, we'll do our quartiles. Okay, so measures of position are going to basically rate each of our scores in comparison to the rest of them. So a z-score is going to measure how many standard deviations we are away from the mean. If our z-score is negative, we're below the mean. If our z-score is positive, we'll be above the mean. So once again, our z-score will measure how many standard deviations a particular value is away from the mean. We can use it to compare scores from two different sets of data and measure their ranking. We'll also use z-scores a lot moving forward in finding probability of certain events happening when we're comparing a value to the mean. So here's our z-score formula. X is our value minus, this is our population mean, standard deviation. So value minus the mean divided by standard deviation. Same formula for a sample. Z-score is our value minus the sample mean divided by the sample standard deviation. Either calculation takes the value, subtracts the mean, and divides it by the standard deviation. Quick little side note for our calculator operations, if you type that all in together, put your numerator in parentheses. Oh, quick example of a z-score. Which score has a higher relative position? A score of 68 on a test with a mean of 75 and a standard deviation of 5.6, or a score of 60 on a test with a mean of 72 and a standard deviation of 7. First z-score. We have a score of 68. Our average, or our mean, is 75, and our standard deviation is 5.6. If we type that in, we obviously have a negative z-score. That z-score is negative 1.25. In other words, the score of 68 is 1 1/4 standard deviations below the mean. Our z-score for our second set of data, we have a raw score of 60, a mean of 72, and a standard deviation of 7. 60 minus 72 divided by 7 gives me a z-score of negative 1.71. As you look at these two z-scores, negative 1.25 is higher, or it's closer to 0. In this case, it's a negative. So the first test score has a higher relative position. They scored higher on this one. This one's 1 1/4 standard deviations below the mean. This one's 1 7/10 standard deviations below the mean. So it's a lower score. Bulk of our work here in this section is going to be on percentiles. Percentiles divide the data into 100 equal groups. A couple other quick definitions. Deciles divided into 10 equal groups, and quartiles into 4 groups. We will look at that in our next lesson. Right now our concentration area is right here. Now percentiles are different than percentages. Percentiles tell us where a score ranks compared to the other scores that have been gathered, or the other values that have been gathered. Percentages, if I hand back your stats test and you got a 50 out of 54, you divide that to get your percentage. That is your percentage that you got right or correct on the test, not your percentile. Okay, your percentile tells you where you rank. Now with our percentiles, we're going to do 3 different things. We're going to find the percentile for a number in a data set. So if we had a set of numbers 1, 2, 5, 7, 12, 16, 22, and I wanted to find the percentile rank for number 16, I'd follow this process here. I'd count the number of values below that given value, so the number of terms below 16, add 0.5 to it, divide it by my total number of values, 1, 2, 3, 4, 5, 6, 7. There are 7 total numbers here, so I divide by 7, and once I have that, I'd multiply by 100%. Okay, so we can find the percentile rank for any number within a data set by following this procedure right here. If we go the other way and we want to find a number that corresponds to a given percentile, so maybe we want to find the 40th percentile, we go through these 3 steps here. Regardless of what we're finding, we always have to arrange the data in order from smallest to largest. Notice I have these written in order from smallest to largest. That way I can count the numbers below it. Step number 2, we calculate a value called C. C equals n times our percent desired. That should be divided by 100 to make it a decimal value, where n is the total number of values. So C equals our total number of values multiplied by our percent we went to here, we'd have 1, 2, 3, 4, 5, 6, 7. 7 times our 40th percentile divided by 100, or we'd get 2.8. If C is not a whole number, 2.8 is not a whole number, we would round that up to 3, and then our percentile, or 40th percentile, is number in that position, so the third position, which would be 5. Okay. If C had been a whole number, so this had been a whole number of 3, we'd go to the number in the third and the fourth position, add those two together, and divide by 2. So it's two different routes to go. If C is not a whole number, round up, go to the number in that position. If C is a whole number, go to that number and the next number up, add those two together, and divide by 2. And here's what that's going to look like. Skip over that top little paragraph there and come back to that. Says find the 25th, the 60th, and then the percentile rank for 4 hours spent on a computer for these office workers. So we have 3 different problems here. 25th percentile, 60th percentile, and then a percentile rank for number 4. Regardless of which one we do first, our numbers have to be in order from smallest to largest. So 0, 1, 1. Looks like we have 3 2s, 3 3s, a 4, and a couple of 6s. We'll start out with the 40th percentile, the 25th percentile, sorry. 25th percentile. To find it, we calculate C first. C is our number of terms, 3, 6, 9, 12. We have 12 total terms, multiplied by the percent we want to try to find, which in this case is the 25th, and we're going to divide that by 100 to get our value. In this case, our value is 3. Since 3 is a whole number, we go to the number in the third position and the fourth position and add those together. So up here, the number in the third position is 1, the number in the fourth position is 2, so we add 1 and 2 together and divide it by 2. That gets us 1.5. That is our 25th percentile. Okay, so again, whole number, we take that number and the next position up, add those together and divide by 2. Our second one, the 60th percentile, we'll show the other route we go. C equals 12 times 60, n times p, divided by 100. This time we do get a decimal value, so C is not a whole number, it's 7.2. So in this case, we round that up to 8, and we go to the number in the 8th position. 1, 2, 3, 4, 5, 6, 7, 8. You can see 3 is in the 8th position, so 3 is the 60th percentile. Again, simply noting with our C value, we go 2 different directions. If we have a whole number, go to the number in that position and the next one up. If we have a decimal value, we always round up, whether it's 7.2 or 7.9, round up to 8. Number in that position is 3. There's our 60th percentile. And our last one here, completely different process. We want to find the percentile rank for number 4. So number 4 is right here. What we do in this case is we count the number of terms below that, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 terms below that. We add 0.5 to that. We divide by our total number of terms, which are 12, and we multiply by 100 to make that a percentile. And if we do that, that is about the 79th percentile. So these 2 processes were the same. This was a completely different process that we went over to start the day. So there's 25th, 60th, and the percentile rank for number 4, 3 separate problems there, so we do have 3 separate answers. Just to make sure we're clear, we're going to go through that a second time. Says find the 40th percentile and the percentile rank for 7 for the number of cups of coffee drank per day. So first thing we're going to do is put these numbers in order from smallest to largest. I have a 2, a couple of 3s, a 4, a 5, a couple of 6s, a 7, 8, and a 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3, 6, 9, 10. So we have all 10 numbers there. We'll start out with our 40th percentile. We calculate that C value. C equals n, which is 10 terms, times our 40th percentile divided by 100. That gets us 4. So we go to the number in the 4th position and the 5th position. So up here, 1, 2, 3, 4th position happens to be 4. 5th position is 5. So in this case, we add those 2 together and then divide those in 2 to find our 40th percentile. Our 40th percentile is 4.5, roughly. And then our second process, we want to find the percentile rank for the number 7. 7 is right here in our data set, so I count the terms below it, 3, 4, 5, 6, 7. There happens to be 7 numbers below that. We always add 0.5 to it. We divide by the total number of terms, which in this case is 10, multiply by 100 to make it a percentile, and the number 7 is about the 75th percentile. So there's a look at our work with a data set and finding percentile ranks in 2 different types of scenarios. I'm going to back up here to the top. If we have a grouped distribution, a frequency distribution, we're going to use a cumulative percentage graph to do that. That is essentially an ogive. Remember our work back in chapter 2 with an ogive. It's going to be a relative frequency ogive that we're going to graph using our boundaries along the x-axis and our cumulative percentages along the y-axis going up to 100%. Then we'll just use the graph to read that information and find the percentiles. Basically, because we're using a graph, it will be somewhat of an estimate. So we'll take a look at that right here. It says find the 20th percentile and the percentile rank for a grade of 85 for these grades in a college algebra class. So the first thing we want to do is we want to convert these to a cumulative relative frequencies. So first thing, 5, 9, 17, there are 24 total values in here. I'm going to go ahead and do a cumulative frequency column here as well, just so we can have that, and hopefully it makes a little bit more sense as we go through here. So to find the cumulative relative frequency, I'm going to take each of these numbers and divide by 24. So 2 divided by 24 will make life simple around the nearest whole percent. 5 divided by 24 is about 21%. 9 divided by 24 is about 38%. 17 divided by 24 is 71%. 22 divided by 24 is 92%. And 24 divided by 24 is 100%. So we're going to plot those values along with our class boundaries. So I will convert these to boundaries along my x-axis. So I'm going to scroll down, and it doesn't look like I can fit that on there, but my first boundary is going to be 34.5. So I'll place that here. Second boundary is 45.5, and I'm going up by 11, so I go 56.5, 67.5, 78.5, 89.5, and 100.5 will be our boundaries, not our classes, although our classes wouldn't make much of a difference, but we will use our boundaries here. And then I'll label my percentages here along the y-axis. Oh, my percentages here, so I'm going to go 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100%. These, just so we have a little bit more frame of reference here, these are our grades, and those are our percentiles there on the left-hand side. If we recall from our graphing procedure with ogives, we always start here at 0 on the x-axis, 0 on the y-axis, I guess I should say. So we're going to plot the 8%, the 21%, the 38%, the 71%, the 92%, and the 100%. And we'll do our best to sketch these into a straight line as much as possible, because now we're going to be able to read that graph. Going back to the top, we want to find the 20th percentile and the percentile rank for a grade of 85. So I'm going to write those down here. I want to find the 20th percentile, and I want to find the percentile rank for a grade of 85. So I'm going to work backwards here, or for my graph, here's the 20th percentile. So I'm going to go straight across until that 20th percentile hits the graph. I'm going to go down and try and come up with my score. So it looks like my score is just below 56.5, so it might be a 54 or a 55. Okay, so you can see because we are reading the graph and we don't have every single tick mark on there, We are going to have to estimate that a little bit, so somewhere around 53, 54, 55, 56 is going to be our answer. Okay, for a grade of 85, notice the grades are along this axis, so 85 is going to be somewhere out in here. So I'm going to go up as straight as I possibly can here. Looks like it hits here and comes across, and we're going to estimate that to be somewhere around the 82nd or 83rd percentile. So 85 ranks in about the 82nd percentile. So again, that's reading our graph. We have to be able to read those, and then now obviously I don't have a ruler I can put on here. You can do a better job of coming with straight lines, straight up and straight across for a little bit more exact estimation, but regardless, it is going to be an estimation using that graph because we don't have a tick mark for each one. And that covers our work for percentiles.